Hello everyone, this is Lynn from the Experience Research Lab. Today I'll show you how to run multinomial logistic regression in RStudio. Technically, multinomial logistic regression is the extension of binary logistic regression. The difference between the two lies in the number of values of the dependent variable. So if the dependent variable in binary logistic regression only has two values, the dependent variable in the multinomial logistic regression may have 3, 4, or even more values. Considering this, I wouldn't expect the model accuracy to be as high as in the binary logistic regression, and you will find out the reason later. Multinomial logistic regression is also closely related to discriminant analysis. The only difference between the two is in the type of measure used for the independent variables. If the discriminant analysis only takes independent scale predictors, the multinomial logistic regression may take different numerical independent predictors, including those in nominal, ordinal, or scale measures. But why RStudio? Why not SPSS or maybe Microsoft Excel? There could be several answers to these questions. As mentioned in the previous video, despite the advanced statistical analysis capability, SPSS is very costly. It is multiple times more expensive than Microsoft Excel, which costs less than $5 per month. The problem with Microsoft Excel is that it cannot read SPSS files. Indeed, I can pay $1 for a monthly subscription to Collectica, and this way I can import files not only from SPSS, but also from Stata and SAS directly to Microsoft Excel. But what if I don't have any extra, even $1? It means I should find an open source data analysis tools, and RStudio is definitely one of the most reliable. Another possible reason, and this is actually the best reason to use RStudio, is that it is currently in very high demand in the data industry. Big chance client will require me to use it for data analysis and data modeling. So let's just do it. Multinomial logistic regression in RStudio. So the first option is by clicking File, Import dataset from SPSS. When the dialog box pop-ups advising me to browse the location of the dataset, I just click Browse and going to the folder where the dataset is located, which is in local disk C, Program Files, IBM, SPSS Statistics, Samples, English, and the file name is telco. Type it here and select. So as shown here, the dataset name is telco and it is saved in SAV format. So this is the preview of the dataset, and to import the files to RStudio, I just need to click import. But for now, I'll click cancel. The second option is by going to the environment here and clicking import dataset from SPSS. The next step will be exactly the same as with the first option. So click browse and find the location of the dataset, which is in the same folder. File name is telco, selected, open. It's retrieving preview data. This is the preview of the dataset. To import, I click import, but again I'll click cancel because I want to show you how to get the dataset with the third option. So the third option is by typing the script here. And to get the dataset this way, I'll need a library. So I type required library here. The first library to get the dataset is library heaven. And to second dataset to analyze the data is library nnet, which stands for neural net. Highlight these two libraries and click run. Now I'm ready to get the dataset from SPSS. Get dataset from SPSS and save it as telco. So the dataset name will be telco, and I can get it by reading the SAP files. I'll just quickly go to the folder where the dataset is located, which is here. Press shift, copy as path, go back to RStudio, paste it here, but I need to replace this with this, all of this. It will take a few seconds of your time. Almost there, and click run. As shown here in the environment, the dataset has 1000 observations and 42 variables. To view the dataset, I just type the dataset name telco and click run. If I just scroll up a little bit, I can see the first few variables: region, tenure, age, marital, address, income, ED for education, employed, retire, gender, reside, toll-free, equip, call card, and wireless. If you're new to RStudio, you might feel a bit overwhelmed looking at this, but do not give up just yet. As you spend more time running different analysis in RStudio, you'll get used to it. Even better, you will later find it easier to make sense of the processes and the results because you are deeply involved in them. I will not analyze all these variables because I'm only interested in several demographic data and using them to build a model to predict the customer categories. The variables I'm interested in are in column 3 to column 11 and column 41. So I'll drop unnecessary columns and create a new data set. Drop unnecessary columns and create a new data set. Save as telco 1 just to make it different. So telco 1 will be the subset of telco, where I drop column 1 to 2, 12 to 40, and column 42. Now I click run again. And to view the dataset, the new one, by the way, here I can see that there are 2 datasets now. The second dataset, telco 1, also has 1000 observations, but only 10 variables. And to view the dataset, the new one, I'll type telco1 and click run. So here is the dataset, the new one. The 10 variables are age, marital, address, income, ED for education, employee, retire, gender, reside, and cascade. So cascade will be the dependent variable. And to see the structure of the variable, I'll type structure of telco1. Run again. As you can see here, cascade is currently an integer, and therefore I need to transform it into a vector. So transform, dependent variable cascade. Just save it as cascade of telco1. As vector of cascade in telco1. Click run. I'll type structure telco1 again. Click run. Now you can see that the cascade is now a vector with 4 levels or values: 1, 2, 3, and 4. What I need to do next is to indicate the reference level. Where the cascade where the cascade in telco1 relabeled with the reference 1. I also want to see the distributions of customer categories in the dataset telco1. So observe categories. Or save it as n, where n is the table of customer category. To see the distribution, just type n, click run. So out of 1000 observations in the second dataset, 266 are classified into the first category, 217 classified into second category, 281 into the third category, and 236 into the fourth category. Now I'll set the first seed with set seed (222) and then click run. I will split the dataset into two subsets of samples and store them as index. So this is partition of data. So store as index two samples of telco 1, and the sampling will be sampling with replacement. True. With the proportion of samples is 3:1, so 75% for the training and 25% for the testing. Click run again. Now I will assign the first subset of samples into training dataset. So training will be the first subset of telco 1. And the testing will be the second subset of telco 1. Run again. As you can see here, there are 4 datasets now. The third dataset is for testing. It has 226 observations with the same number of variables, 10. And the training has 774 observations and 10 variables as well. Now I'm ready to build the model. Build the model, where the model will be built with multinom package. Multinom and the dependent variable will be the customer category and other variables as independent variables. So the data for the model will be from training dataset. Run the model. Here I can see the number of iterations taken to get the parameter estimates converge. So it takes 30 iterations with the initial value of 1072.99 and the final value of 968.94. To see the model, I'll type summary model and then run. In the model summary, I can see the coefficients and standard error of each variable. But unfortunately, the multinom package doesn't include the p-value calculation for the regression coefficients. But I can calculate it using two-tailed z-test. So to calculate the p-value, I need to first calculate the z. Just type this one first using two-tailed z-test, where z will be the sum of coefficients in the model divided by the summary or the sum of standard errors in the model. Run the Z. Now I can calculate the p-values, where the p-values will be 1 minus p-values of normal distribution with the absolute value of Z and mean of 0 and standard deviation of 1 multiplied by 2 because it is calculated with 2-tailed z-test. Run the p-values. Now I'll type p and then run again to see the p-values of each variable. Here I am looking for variables with p-values lower than 0.5. The first variable h, the p-values are lower than 0.5 in first, second, and third equations. Maritals are also lower than 0.5. Address as well. Income, the p-value is higher than 0.5 in the first equation, but are still lower than 0.5 in the second and third equations. So I can still keep the variable in the model. ED or education, the p-values are far lower than 0.5 in all equations. Actually, these are the best. Employee, the p-values are also lower than 0.5 in all equations. Retire, the p-values are higher than 0.5 in the first and third equations, but is still lower than 0.5 in the second equation. So I can still keep this variable in the model as well. Gender, the p-value is higher than 0.5 in the first equation, but are still lower than 0.5 in the second and third equations. I can keep this as well. The last variable, reside, the p-values are higher than 0.5 in the first and second equations, but is still lower than 0.5 in the third equations. That is to say that I can keep all these variables in the model because they all show significant relationship with the dependent variable customer categories. I can now predict the customer categories with training data, but before I do that, let me first see the distribution of customer categories in training data. So, predict customer categories with training data, where the distribution of customer categories in training data will be the table of customer category in training data. Great. Now I run it and table, sorry. Great. Yep. And to see the customer distributions in the training data, I just type training and then click run. So out of these 774 observations in the training data, 202 are classified into the first category, 169 into the second category, 228 into the third category, and 175 into the fourth category. Now let us do the first prediction with the training data, where I will save the prediction as pred, where pred is the prediction using the model, and training data. Now I will create a table comprising the prediction and customer category in the training data. To see the table, I can type tab and then click run. This table is also called the confusion matrix table. Here I can see that out of 202 observations classified into the first category, only 79 are correctly predicted. Out of 169 observations classified into the second category, only 18 are correctly classified. Out of 228 observations classified into the third category, only 127 are correctly predicted. And out of 175 observations classified into the fourth category, 78 are correctly predicted. If I type tab divided by the sums of values in each column in the table and click run, I can get the percentage of model accuracy for each category. So the model accuracy to predict the first category is 39.11%. To predict the second category is 10.65%. The third category is 55.70%, while the model accuracy to predict the fourth category is 44.57%. So if I sum the values in the diagonal line of the table and divide it by the sum of values in the table, I can get the overall accuracy to predict the customer categories using the training data. Click run. So the model accuracy to predict the customer categories using the training data is 39.02%. On that note, the misclassification error will be 1 minus the model accuracy. Sum of values in the diagonal line of the table divided by sum of values in the table. This is the misclassification error, 60.98%. Is it a good thing? I cannot tell yet, but I can assess the model by doing the second prediction using the testing data. So let us do the prediction using the testing data. And before that, I'll get the data distributions on the customer categories and the testing data, where the end testing will be the table of customer category in testing data. Great. To see the data distribution, type end testing, run. So out of 226 observations in the testing data, 64 are classified into the first category, 48 into the second category, 53 into the third category, and 61 into the fourth category. Now I'll do the prediction and save the prediction as spread 1, where the prediction will be using the model and testing data. I will also create another table, call it as step 1, where step 1 will be the table comprising the prediction 1, spread 1, and customer category in testing data. Great. To see the table 1, I type tab 1 and run. This is the second confusion matrix. So out of 64 observations classified into the first category, 28 are correctly predicted. Out of 48 observations classified into the second category, only 3 are correctly predicted. Out of 53 observations classified into the third category, 20 are correctly predicted, and out of 61 observations classified into the fourth category, 32 are correctly predicted. To get the percentage of model accuracy, I'll divide the sum of tab 1 with the sum of each column in the tab 1. So the model accuracy to predict the customer categories using the testing data is 43.75% for the first category, 6.25% for the second category, 37.74% for the third category, and 52.46% for the fourth category. Overall, the model accuracy is the sum of values in the diagonal of line of tab 1 divided by the sum of values of tab 1. It is 36.73%. If I just scroll up, the model accuracy using the testing data is 39.02%. So it is 0.3 lower than training data. And that's to say the misclassification error using the testing data will be a little bit higher, which is 1 minus sum of diagonal values in tab 1 divided by the sum of values in tab 1. Right. As mentioned early on, the model accuracy is not that high, and it is not necessarily a bad sign. It turns out that the first and second predictions are not much different, and on that note, I can say that the model does an excellent job in predicting the fourth category. However, it seems to be not working as expected in predicting the second category. So that is how to run multinomial logistic regression in RStudio. If you have any questions, please feel free to leave a comment. For more insights into data, including data collection, data entry, data transformation, and data analysis in RStudio, SPSS, or Microsoft Excel, please subscribe, listen, and watch our content that is available in text, audio, and video format. Thank you for being with me today. I'll see you next time in the other videos. Cheers!